Alright, the next thing we're going to look at is solving radical equations. And a radical equation is just an equation where the radicand, remember that's just what's under the radical, contains a variable. So if you look at the examples down here, you see I have square root of x plus 3 under the radical, so that variable is under the root equals 8, or cube root of x minus 1 plus 2 equals 9. So in order to solve these equations, we're going to use what's called the principle of powers, which says if a equals b, then a squared equals b squared. So basically, if you look at this first equation like this is a equals b, then it says as long as that a equals that b, I don't change the equation by squaring both sides. Okay? Why would I square both sides? The stuff that we've been working on so far, the way I've been making you write the problems out, is because we know that if the index and the root is the same, then I can remove the root. So that's what we're trying to do for these, is get that variable from underneath the root. All right? So the steps for solving a radical equation. First, we want to isolate the radical term on one side of the equation. Basically, all that means is usually your radical is going to be on the left. You want to make sure that the only thing on the side with the radical, that everything is underneath. So just a quick peek to show you what I'm talking about. Look at number 1 and number 3. For number 1, everything on the side with the radical is under the radical. That's what we want. Where number 3, the 3x minus 8 is under the root, but the 9 is not. So that one is going to require us to manipulate it first, okay? So for this first one, since the radical term is isolated, we can go ahead and use the principle of powers. So since this is a square root, what will undo that is to square both sides. So we know that the index and root will cancel. That leaves me with x plus 1 equals 5 squared is 25. And then this is just a linear equation with x to the first. So all I need to do is subtract the 1, and I get x equals 24. Now number 3, and you see in the instructions, says that we have to check all potential solutions. So this isn't one of those situations where I'm just having you check to make sure you got the right answer. Sometimes when we use the principle of powers, we will get solutions that don't actually satisfy the equation. And that's because things that we've done before to solve equations, like adding something to both sides, subtracting something to both sides, multiplying or dividing, those don't innately change the nature of the numbers, where sometimes squaring or raising to the third might. For instance, if you square a negative number, you get a positive. So for all of these problems, when we solve a radical equation, we do have to check back in the original and make sure that it does actually work. So we're going to check x equals 24. Always go back to the original. In the place of x, I'll put 24. And we want to know if this is a true statement. So this gives me the square root of 25 equals 5. And that does give me 5 equals 5, which is true. So that means the 24 is an actual solution. So you can give the answer for these as the variable equals the answer, or if you prefer, you can give it like this. Okay? Alright, the next one, on the left-hand side, again, the radical term is the only thing over there. There's nothing outside the radical. So we're ready to use the principle of powers. But this time, notice that my index is 3. This is a cube root. So we're not going to square both sides. We're going to cube both sides. Okay? And I probably should have done this over here. Sometimes teachers are as bad as what we try to tell you guys not to do. And, we leave off stuff and then forget that it's hard for a student who's learning to know when it's required and when it's not. Anytime you're raising something to a power, you should use a parenthesis. Okay? On the left-hand side over here, my exponent and my index is going to cancel each other out. And then if I multiply -4 times itself 3 times, I get -64. And again, this is linear, so I'm going to subtract 1, and I get x equals -65. So, of course, we're going to need to check. So if we replace x with -65, we want to know if this is true. So underneath -65 and 1 is -64. And that does leave me with -4 equals -4. So that means that x is -65 is the solution. And of course, you can write it either way again. Okay? Alright, so let's look at one where the radical is not already isolated. So remember, we talked about this in the beginning, that for number 3, we have that 9 that is not underneath the radical. So the first thing you have to do before you do anything else, we have to subtract that 9 so that the only thing we have on the side with the radical is underneath the radical. Nothing can be outside. So 5 and -9 is -4. Now that it's isolated, now we can use principle of powers. This one is a square root again. So I'm going to square both sides. So on this side, they're going to cancel, leaving me with 3x minus 8. And on the right-hand side, this is why that parenthesis is important. This is -4 times -4, which is +16. This is a linear equation again. So I'm going to add the 8. And I get 3x equals 24. Divide by 3. And we get x equals to 8. So of course, that's my potential solution. We need to see if it actually works in the problem. So in the place of x, I'm going to put 8. Make sure you put it into the original again. So underneath, I used the calculator and did 3 times 8 minus 8. I got root 16 plus 9 equals 5. So this is going to be 4 plus 9 is equal to 5. And 4 plus 9 is 13. That does not equal 5. So this is one of those situations where my potential solution does not actually satisfy the equation. So the answer here is no solution. We only had one potential solution. It did not satisfy the equation, so we have no solution. All right, for number 4, we've got a similar situation to number 3. I have something outside the radical, so I'm going to need to start by moving that over. Then we can use our principle of powers. It's a square root, so we're going to square. And on this side, they're going to cancel. But on that right-hand side, I want you to be very careful here now. Don't forget when you do this, that's squaring a binomial. So you can FOIL, you can distribute, you can use the box. We actually learned a shortcut for squaring binomials, if you remember. So I'm going to use a shortcut. You can use any of those methods, just don't forget that you do have to multiply that all the way out. The shortcut when we're squaring it, because it's times itself, remember it's a squared, so it's going to be x times itself. There's a plus in the problem, so this is plus. And then it's 2 times each one of the terms plus the last term squared. So 3 squared is 9. You do not have to use the shortcut. This gives me 6x plus 9. Now this one is the first one we've gotten that my highest power is an x squared, so this is quadratic. So we're going to need to use the zero factor property for this one. So that means I have to be equal to 0. And I like for my lead term, if I'm going to have to factor, to be positive. So my x squared term is positive where it is. So I'm going to move these 2 terms over to this side so I can keep my squared term positive. So that's going to leave me with 0 is x squared plus 4x minus 12. So now we need to factor that out. I've got an a equal to 1, so we know this is x and x. The factors of 12 that can give me 4 are 6 and 2. And if we want that 4 to be positive, we need plus 6 minus 2. So this is back to the first test, right? Then we use the zero factor property to set both of the factors equal to 0. I get x equals to negative 6 and x equals to 2. So I have 2 potential solutions, and we're going to need to check them both. And I'm going to need some more space, so I'm going to pause this for a second and see if I can get a blank piece up.